Welcome to our presentation on Cuttlefish, an innovative multi-agent RAG system designed specifically for software operations. This cutting-edge solution represents a significant advancement in how we handle Jira ticket analysis and incident support. By leveraging multiple specialized agents working in concert, Cuttlefish brings a new level of intelligence to software operations management, helping teams quickly identify, analyze, and resolve issues more effectively than ever before. Why Cuttlefish? In most organizations, Jira tickets contain a goldmine of operational knowledge. Yet, this information often remains hidden and underutilized. Conventional tools fail to extract meaningful insights from these tickets. On top of that, documentation is increasingly outdated and no longer reflects the actual state of systems. Teams rely heavily on ticket trails and tribal knowledge, which creates a major gap in understanding. Lastly, when it comes to analysis, existing tools struggle to make sense of unstructured ticket data, making it hard to proactively detect issues or connect related events. Cuttlefish was built to address these exact challenges. Also, from 25 years of experience dealing with production incidents, the 5 most common root causes are 1. Bad releases. 2. Expired certificates. 3. Resource exhaustion. 4. Module crashes. 5. External service failures. Cuttlefish is designed to detect and reason about these common patterns using historical ticket data and intelligent web and log retrieval. Cuttlefish is the product of multiple iterations and years of hands-on learning. It began in 2020 as Octopus, a simple bug classifier using TensorFlow, AWS Blazing Text, and Google AutoML. In 2021, it evolved into Cuttlefish 1, which used the word2vec word embedding generated by Blazing Text and cosine similarity to identify similar Jira tickets. Fast forward to 2025, we now have Cuttlefish 2 and 3. These versions introduced RAG or Retrieval Augmented Generation, then AI agents. The latest version, Cuttlefish 4, adds web and log search for enhanced incident diagnosis. It's no longer just a retriever, it's an intelligent analyst for software operations. The project had 4 main goals. First, build and evaluate different RAG retrieval methods tailored specifically for the structure and language of Jira tickets. Second, design a multi-agent system where each agent has a role, some search, some write, some reason. Third, build a real working prototype that can be tested against real-world scenarios. And finally, explore advanced capabilities like release ticket tracing and integrated log search. These goals drove every architectural and design decision behind Cuttlefish. Let's look at how the system is structured. On the front end, as you will see in the demo later, there is a 2-tab interface where users can issue queries and can even flag issues as urgent or production critical. Behind the scenes is a robust fast API backend, powered by OpenAI models and the LangChain ecosystem. The system uses Google OAuth for authentication and relies on JSON Web Tokens for secure API access. Unlike chatbot UIs, Cuttlefish is intentionally designed as a task-focused assistant, structured, direct, and explainable. The architecture is powered by a multi-agent network. At the top sits the supervisor agent, which orchestrates the entire workflow. The worker agents are RAG agents, a web search agent, a log search agent, response writer agent to take all the findings and compose a coherent final answer. The system uses OpenAI's embedding models for semantic search and Cohere's re-ranker for accuracy. Data is stored in Supabase, which handles both vector and keyword search seamlessly. The RAG portion of the system was evaluated using the RAGAS framework with a golden generated data set and using the standard RAGAS metrics. A comprehensive document of the evaluation can be found at the listed Medium article link here. Before we go through the demo, here's the data that is in the simulated environment. 40,000 open source Jira tickets, 2,000 synthetic release tickets, 5,000 synthetic log4j entries. Okay, let's get to the demo. This is the Cuttlefish UI. First, we need to sign in by clicking on the Google Sign In button and selecting our Google account. Okay, now we are in the main query page. As you can see, we have selected the Not Urgent button, so the system will use the ensemble RAG retrieval to get most relevant tickets to perform the analysis. The system has pre-generated reference questions by analyzing the ingested data. We are now selecting one to use as a query. Now we trigger the multi-agent system to perform the search on the ingested JIRA tickets. The processing could be slow as we are using a combination of RAG retrieval methods to obtain a rich context. Once the context has been obtained, the response writer agent then formulates the response by first analyzing the query and then the retrieved JIRA tickets. The UI displays both the analysis as well as the tickets retrieved. Okay. Now we will perform a query for a production incident. Here we have a simulated e-commerce service go down and payments are failing. Let's see what Cuttlefish finds. Cuttlefish will search the web for any known outages from sites like status pages, Down Detector, or even Twitter. It will also check release tickets or known bugs. As it is a production incident, it will also check logs for module failures, certificate expiry, resource exhaustion like disk space full, max file handles, or connection pool exhaustion. As you can see, Cuttlefish has analyzed the findings from the log search, web search, and JIRA ticket RAG search. This helps the incident commander and the incident team prioritize what to zoom in to investigate to resolve the production incident. In an actual deployment of Cuttlefish, we will link the JIRA tickets and log search entries to the actual JIRA instance and log management system to make it easier for the incident team to zoom in. This ends our demo of Cuttlefish. Please feel free to reach out to us if you have queries or feedback. The development of Cuttlefish represents a remarkable achievement in rapid system development. In just 3 weeks, a single developer designed, built, and tested both the front-end and back-end components. Our testing framework is comprehensive, covering everything from Supabase ingestion and retrieval verification to GCP logging integration. We've implemented thorough testing protocols for individual agents, end-to-end workflows, and API endpoints, ensuring robust system performance and reliability. And it's a wrap. The system is available to try out, but you'll need to fill in a form so that we can grant you limited access. We're looking forward to your feedback and we're happy to explore potential opportunities for collaboration.